Hello everyone! In this tutorial we explain how to download, install and use Llama 3.2 1 billion parameter and 3 billion parameter large language models in Python on a local Windows computer. For those of you who are not familiar with Llama 3.2 1 billion and 3 billion parameter models are lightweight models that can be efficiently executed on desktop computers with modest hardware as well as on edge devices. As such, they are very attractive for building local AI applications, Internet of Things AI applications, and local RAG applications. Here is a brief demonstration of what you will learn in this video tutorial. Here you can see a Python code file that demonstrates how to use Llama 3.2 1 billion parameter model. And here's the big picture. We are asking our large language model what is quantum mechanics. However, we are also providing additional instructions. That is, we are saying the following. You are an elementary school teacher and you need to adapt your answers to elementary school children. That is, not only that we are asking a question, but we also want our large language model to formulate the answers such that elementary school children can understand it. That is, we are running an instruction model. An instruction model can accept the question, but it also accepts additional instructions. For example, over here, you can also say that you want the answer to be formulated in a funny way or in a complex way, or you want to use some other language, etc. This is really powerful. Let's run this code. I will run this code on my local computer that has NVIDIA 3090 GPU with 24 GB of VRAM and 48 GB of RAM memory, and you will see that the answer is generated literally in 5 to 10 seconds. So let's run the file and let's see the answer. Now the model is actually being loaded from our local disk, and let's see the response. And here it is. It may be past 5 to 15 seconds in between. Okay, so here's the answer, and you can see that the answer is written such that a young child can understand it. Quantum mechanics is a way of understanding the tiny things in our world, like atoms and particles that are too small to see. It's a big concept, but I'll try to explain it in a way that's easy to understand. You know how things can be either big or small, right? Like a toy car is big and a leaf is small. Well, at a really small scale, the things start to behave in weird ways. And this is really a formulation in the answer such that a child that has, for example, 10 or 12 years can understand. But before we start with explanations, here are important notes. First of all, there are at least two approaches for running Llama 3.2 locally in Python. The first approach is to download and use Llama 3.2 models by using the Llama framework and the Llama Python library. We covered this approach in our previous tutorial, and I'm going to provide a link to that tutorial in the description below this video. The second approach is to download and use Llama 3.2 models by directly downloading the models from the Hugging Face website and by running a local Python script. And this approach is covered in this tutorial. Here are prerequisites. First of all, you need to have around 10 GB of space on your disk to download both models and to install all the Python libraries necessary to run these models. We have tested the models on a computer with NVIDIA 3090 GPU, which has 24 GB of VRAM. It's a 2-year-old computer with 48 GB of RAM. The model should work on computers with less powerful GPUs and with less RAM memory. Then we have to make sure that you have Microsoft Visual Studio C++ compilers installed on your system. Otherwise, you might not be able to install and run PyTorch properly. To install C++ compiler, you need to download and install Microsoft Visual Studio with C++ Community Edition from this link. That is, you need to go to this web page, or you can simply Google develop C and C++ applications, and then over here you need to select the option, you need to select the community option, click here, and the community edition will be downloaded, and then simply execute this file and Visual Studio C++ will be installed. It might take maybe even 15 minutes to install Visual Studio C++, however you will need this compiler in order to properly run PyTorch. Don't forget to do that. Okay, let's continue. Then, as a demonstration, in this tutorial we use Instruct models. And I demonstrated Instruct models at the beginning of this video tutorial. However, everything explained in this tutorial can be used for Bayes or chat models. Instruct models are trained and used by using instructions. We give instructions on how to respond or what style of responses we want to receive. While generating the response, the model follows the instructions, and you have seen this at the beginning of this tutorial. Here's the copyright notice. This tutorial should not be reposted, re-uploaded, or downloaded without the permission of Alexander Haber. Then, this tutorial should not be used as official or unofficial lecture material in university courses or on online learning platforms. Finally, this manual should not be reposted on public or private websites. Over here you can see a detailed manual that I created and that explains all the steps that you need to perform in order to download the model and in order to create a virtual Python environment and install all the packages. Then I also write 2 code files explaining how to download and how to use the model. I will provide a link to this manual and to all the code files presented in this video tutorial in the description below this video. Okay, let's start. The first thing that you need to do is to register a free Hugging Face account such that you can access the model and such that you can download the model. To do that, you need to go to Hugging Face account, then you need to click on sign up, then you need to enter your email address, password, and just follow these steps and you will be able to register a free account. And we can go from there. But before I start with explanations, I need to mention the following. If you go to the Hugging Face website and if you search for Llama 3.2, you will see not only a single model, you will see a number of models. To demonstrate this, I will just go to the Meta Llama page, and if you go all the way down, you will see the collections. For example, you have this model, Llama 3.2, 1 billion, then Llama 3.2, 3 billion, Llama 3.2, 1 billion Instruct, and Llama 3.2, 3 billion Instruct. Then you have evaluation models, and you also have some other models. In this video tutorial, I will explain how to install this model, Llama 3.2 1 billion Instruct, and this is the smallest instruction model that you can find, at least on Llama webpage. However, everything that I will explain in this video tutorial applies to any model that you can see over here. Usually we have Bayes, Instruct, and evaluation model. Instruction model are explained at the beginning of this video tutorial. Beside the question, we also provide an instruction, and this instruction is used to shape our answer. Bayes models, that is these 2 models, are mainly used for chat. Evaluation models are used for more advanced users. That is, they're used by people who are experienced and who are developers. If you're complete beginners, you should either start with these instruction models or with the Bayes models. I like instruction models better since they enable you to shape the answer, and you can, for example, produce an angry answer or sarcastic answer, or you can put some emotions in the answer and the answer will sound more realistic. That is, it will not sound dry or like a computer-generated response. Go to the Hugging Face website and over here, search for Llama 3.2 1 billion Instruct. Click here, then click here on Expand to review and access, scroll all the way down, over here enter your personal data, and then click here and click on Submit. After you click on Submit, you need to wait for a while for your access to be approved. And you can check your access by clicking over here. And you will see this menu. You can see that the request status is currently pending. So wait for a while, maybe 10 or 15 minutes until your access is approved. And after some time, if you check the status, you will see accepted over here and we can continue. After you obtain the access to the model, we need to create a token. A token is a password that's used to access the model. To do that, click over here, then click on Settings, then over here, find Access Tokens, then click on Create New Token and give the name to your token, token1 new or a similar name, then make sure that this option is selected and then scroll all the way down and click on Create Token. After you click on Create Token, a new token will be created. It's a sequence of letters and numbers, and make sure that you copy it and that you save it somewhere, since you will need to enter this token in order to download the model. The next goal is to create a workspace folder, Python virtual environment, to download the model and write and execute the Python test file. Here we will explain how to download and install 1 billion parameter Instruct model. The same procedure applies to the 3 billion parameter model or any other model in the Llama 3.2 family, that is to evaluation, instruction, or base models. The first step is to create the Python virtual environment. To do that, we will need to open a Windows command prompt and to create several subfolders and to create a Python virtual environment. Let's do that. Click here and search for command prompt. Open the command prompt. Now, here's my strategy for setting up everything. Usually, I like to go to the base folder, that is to my base C drive, and inside of this folder, I will create another folder called codes. I will not execute this command since I already have codes on my C drive. However, you should execute this command. After you execute this command, navigate to the codes folder, and over here we need to create an additional folder. Inside of this folder, we will create another folder called Llama 1B, where 1B of course stands for 1 billion parameter. Then let's navigate to that folder, and in this folder we will create our Python virtual environment. To create the Python virtual environment, we need to call Python with an option M, then we need to use this command venv for creating virtual environment, and we need to specify the name of our virtual environment. I will call the virtual environment simply as environment1, and this command will create our virtual environment. Be patient over here. The next step is to activate our Python virtual environment. To do that, we need to execute this file, activate.bat. This is actually a script file that is located in this folder, and then inside there is a scripts folder, and then we will execute this file. However, we don't need to go to this subfolder. We can simply type over here this thing, and this will execute the command, the script, and over here you will see that our Python virtual environment is now active, and now we are ready to install the Python packages and libraries. The first step is to install PyTorch. However, I will stop here for a second and I will again mention that you need to have Microsoft Visual Studio C++ compilers installed. I explained how to do that, that is how to install the C++ compiler at the beginning of this tutorial. Consequently, if you don't have Microsoft Visual Studio C++ Community Edition installed, stop here, go at the beginning of the tutorial and install it, and then continue. If you don't do it, you will not be able to install PyTorch and you will not be able to run this code. Now, to install PyTorch, don't simply type here pip install PyTorch. you will create a grave mistake and the code will not work. The proper way is to install PyTorch CUDA version. To do that, follow this link or simply search PyTorch, install locally in Google, and then you will see this selection table. Here select the stable version, click on Windows, click on pip or pipe, click on Python, and over here I will select CUDA 12.1. However, I noticed that it really doesn't matter if you select this CUDA version or this CUDA version. You might test all the options. And once I click here, this command will be generated. You can simply copy this command, go back to your terminal and execute it. Now, it will take a while for PyTorch to be installed, maybe even 2 to 3 minutes, since PyTorch is around 3 GB. Consequently, be patient. Next, we need to install the Hugging Face Hub library. This library will be used to download our model. Consequently, let's type pip or pipe install, then Hugging Face, and then _hub. And this library will also take a while to install. Oh, not too bad. Then you need to install transformers. However, make sure that you install transformers with this option upgrade, otherwise you're not going to install the proper version of transformers. So let's execute this command. And again, it might take a while to install transformers. So be patient. And here's the last library that we need to install. And it took me basically maybe even 1 hour to figure out and to debug everything in order to figure out that I need to install pip accelerate, but not only pip accelerate, I need to select pip accelerate whose version is larger than 0.260. And this is really important, otherwise the code will not run. And this was good. The next step is to write a Python script that will download, or better to say, pull the remote model. That is, that will download the model from the Hugging Face website. Here, you can open your favorite Python editor. In my case, I'm using Visual Studio Code. Consequently, I will type code with a period or with a dot. And this will open the Visual Studio Code. I will click yes, I trust the authors, and then I will create a new file. File, new file, and I will call this file test1.py. Or not like that, let's call it like the download.py, since we want to download everything. And make sure that you save this file inside of this base folder. This is really important. Okay, now to save some time, I will simply copy and paste the content of the file that I wrote. And here it is. Let's explain this file line by line. From Hugging Face Hub, we are importing the library called, or not the library, better to say the function, snapshot download. This function is used to download the model. To download the model, we need to specify 3 things. The first thing is the ID of our remote repository. How to find this ID? Well, go to the Hugging Face website and search Llama 3.2, and let's find our model. Where is our model? It is this one, right? It's the model. Now, the ID of this model is given here. You can simply copy it here, then go back to this download folder and simply paste it, and that's it. The next thing that you need to insert is your token. So your token that you generated on the Hugging Face website goes here. So simply copy and paste the token over here, and the token is used to log in. That is, to download the files, we need to log in. And the next thing that you need to specify is the download folder. In our case, the download folder is given over here. And let me just copy here for a second in order to explain how to write the path. You can compare these two paths. If you want to specify the path, you need to use this double backslash, and this is how you do it. And make sure that these paths are correct. Of course, you don't have the last symbol over here, and that's it. Save this and execute this file. Over here, I wrote a fake token in order to explain how the token should look like. Every token should start with HF, and then you will have underscored, and then you will have these letters over here. So consequently, your token should look like somehow like this. To run this file, you first need to select the Python interpreter. If you're using the Visual Studio Code, press Ctrl-Shift-P and then search for Python select interpreter. And here it is. Make sure that you select this Python interpreter inside of our virtual environment, and then after that you can click here to download everything. I inserted my correct token that you cannot see right now, and the download process started, and you can see what's being downloaded. We are downloading model.savetensor files, and you can see they're huge. Then we have these other files, they're also big. And it's going to take a while to download everything, so be patient. What we are currently downloading are the files given over here, and you can see them here. You can see this model save tensors, which is a huge file. Then over here under original, you also have another file. So let's download everything, and again, it's going to take a while to download these files, maybe even 5 minutes. Consequently, be patient. Then, after approximately several minutes, the model is downloaded. Let's inspect the model files. Go to the base folder and let's see the size of the folder. We can see that the folder is almost 10 gigabytes. This is because we have downloaded PyTorch, we have downloaded transformers, accelerate, as well as the model files. And if you click here, you can see the model files, these huge files, for example, this one over here and another one over here. Another thing to notice is that our virtual environment folder is also huge. It is around 5 gigabytes. And finally, after the model is downloaded, we can write our Python code. Let's create a Python file that implements our code. Click on File, New File, and call this file test-llama.py. And make sure that this file is saved in the base folder. Over here, to save the time, I will simply paste the content of the file. Here it is. And let's explain this file line by line. First, from transformers, we need to import pipeline. Pipeline will be used to load the model and to perform the inference. Then, we need to import torch. Next, we need to specify the local model path. That is, we need to specify the path of the folder in which the model is downloaded. In our case, the model is downloaded over here, and you can see all the files. And consequently, the path should look like this, and compare this path with the Windows path. Next, we need to define our pipe. For that purpose, we use pipeline. We specify that we want to perform text generation, then we specify the path to our model, then we specify torch data type, pfloat16, and over here we specify device map to be auto. Auto means that we are telling to pipeline to automatically recognize if we have a GPU installed on the system. If we have GPU, then auto will return CUDA, and then we will be using our GPU. Otherwise, if you don't have a GPU, CPU will be used. Over here, we define the message structure. The message structure contains 2 entries, and it's really important to understand what's happening over here. It's actually a list with 2 entries. The first entry represents role, system, and content. What we are saying over here is to create a response with a specific style. And here is the style, or here is the context in which the answer will be generated. You're an elementary school teacher and you need to adapt your answers to elementary school children. What we are saying to our large language model is to generate an answer such that everyone can understand it. That is, even a kid can understand it. And over here, the second entry is the dictionary defining our question. And the question is quite complex. What is quantum mechanics? And it's very difficult to provide an answer to this question such that an elementary school kid can understand it. This is really important. Okay, so this was our question. Of course, you can play with this question. You can play with this style. Over here, as a style, you can, for example, say, generate a funny answer, or generate an angry answer, or generate an answer that no one can understand, or generate an answer that only people with PhDs can understand, etc. And here's another example of a message. Over here, again, I'm saying to generate a message such that even an elementary school children can understand it, and I'm asking what is machine learning. And you can see over here that I commented this message structure. I will ask it later on. Once you define the message structure, you need to call pipe. You call pipe, you specify message structure as the first input parameter, then you specify max new tokens. You can play with these parameters to increase the size of the answer. For example, you can even specify 1000, it will work perfectly. And over here we extract the response. The response is stored in this dictionary output response, and if you actually want to get the string, that is the text, you need to call output response with the content, where the content is the key that will bring you the string, and we simply print it out. However, we also want to save the answer in the file such that we can use it somewhere else. To do that, we use with open as text file. What will happen over here, we are going to open a file output.txt. If this file doesn't exist, it will be created. We will open it in the write mode. We will use this encoding. If you don't use this encoding, Python will complain, and we open it as text file. And inside we simply call text file.write, and we say output response with the key content, and this will actually save or write the string generated by the large language model. Simple as that. And finally, we are ready to run our file. To run the file, press and hold Ctrl Shift P, then search for Python, select interpreter, click here. Make sure that you select the Python interpreter inside of the virtual environment, and then simply click here and enjoy. The answer will be generated. So now let's see. You can ignore this warning sign, and here it is. Here is the answer. Imagine you have a toy box filled with different color balls. Each ball represents a tiny particle like an electron. Now when you reach into the box and grab a ball, you expect it to be of one color, right? And you can see that this answer implies some probability here. However, it's being written such that basically elementary school children can understand it. And we can retrieve the answer by going to our base folder, and the answer is stored in this file output.txt, and you can open this file and you can see the answer. Here it is. Now, I'm really curious to learn how this software will answer this question. That is the second one about machine learning. Consequently, let's comment the first question. You can do it like this. And then over here, let's uncomment this part. And don't forget to change the number here to 2. Save the file and let's run it. However, before run it, let's make sure that output.txt file is erased, although the software will automatically override this file. Okay, so let's run this and let's see. Again, let's see what's happening. And here it is. Oh boy, are you ready for a cool idea? Machine learning is like having a super smart computer friend that can help us make decisions on its own. Very good. Imagine you have a toy box filled with different toys and you want to find a toy that you lost a long time ago. You can use a special computer program to look through the toys and find the one that looks like the one you lost. This is also really interesting. Now, for those of you who are high school teachers or elementary school teacher, this software can be very useful to inspire you in how to explain things to people who don't have any background or who are children or old people who don't have any background or any technical knowledge. Okay, that's all for today and thanks for watching.